Alright, so in this video, I'm going to be trying to find the area of the red triangle inside of the square. So this is the red triangle right here, and we want to find just the area of this. So we are given that this side of the red triangle is equal to 18 meters squared, this side is 48 meters squared, and this side is 18 meters squared. So what I'm first going to do is I'm going to set the distance from here to the endpoint of this triangle as x, and I'm going to set this distance from the endpoint of the triangle to the endpoint of the square as y. And I'm going to set this whole side. See, before I do that, I'm going to set this equal to w, and this equal to, this is again x. So meaning this whole side, or sorry, this should be z. So now this whole side is going to be w plus c, and this whole side is going to be x plus y. So now from here, I can say that because this is 48 meters squared, I can say that x plus y times z over 2 is equal to 48, because 48 is the area of this white triangle right here. So we can also say that because 18 is the area of this triangle right here, we can say that w plus z times y over 2 is equal to 18. And finally, this is also equal to 18, so we can say that w times x over 2 is equal to 18. So we have three equations right here. And finally, the last equation is that w plus z, because this is a square, all side lengths are equal to each other, meaning w plus z is equal to x plus y. So now from here, what I'm going to do is, for these three equations, I'm going to multiply both sides by 2 just to get rid of this division right here. So now they turn into x plus y times z is equal to 96, w plus z times y is equal to 36, and w times x is equal to 36. So now going back over here, we have this equation right here, w plus z is equal to x plus y. I'm going to subtract z on both sides. So this turns into w is equal to x plus y minus z. And now, what I'm going to do is I can say that z is equal to, if I divide both sides by x plus y, z is equal to 96 over x plus y. And this also turns into, if I plug in the value of w for right here, I get x plus y minus c plus c times y, which is equal to x plus y times y is equal to 36. And finally for this one, this turns into x plus y minus z times x is equal to 36. And now if I distribute the x, I get x squared plus xy minus xz is equal to 36. And I can subtract x squared and xy on both sides. So then these two cancel out, and I'm left with negative xz is equal to 36 minus x squared minus xy. And finally, I'm going to divide both sides by negative x. And because I'm dividing by negative, all the signs are going to change. So this turns into 36 minus x squared minus xy over negative x, which is equal to negative 36 plus x squared plus xy over x. So this is the value of z. Now after doing all of this, I get, here are my three final equations. I have negative 36 plus x squared plus xy over x is equal to 96 over x plus y. X plus y times y is equal to 36, and z is equal to negative 36 plus x squared plus xy over x. By the way, this is xy. So meaning z is equal to 96 over x plus y. Now what I'm going to do is I'm going to graph these two on Desmos. So if I graph it on Desmos, what I get is right here, and the point where they two intersect is 9, 3, and that's going to be our solution. So this means that x is equal to 9 and y is equal to 3. So now we can use this to solve for the rest of the variables. So if x equals 9 and y equals 3, I can first start by plugging in this over here. So I get z is equal to negative 36 plus x squared, which is 9 squared, plus x times y, which is 9 times 3, which is 27, over x, which is 9. And this turns into 8. So z is equal to 8. So we know that x is equal to 9, y is equal to 3, and z is equal to 8. So this side that we initially put as x, we can say is 9. This we said as y, so this is 3. This is going to be 12. This is 12. This is 8. And this is w, which we still don't know the value of. But if this whole thing is 12, this whole thing is 12, this whole thing is 12, then this must equal 12 as well, meaning w is 4. So now the area of this red triangle right here, this is going to equal the entire area of the square minus the area of these three triangles right here. So minus the area of these small triangles. So the total area of the entire square is 12 squared, which is 144. And I get this minus the total area of these three white triangles, which is 18 minus 18 minus 48. And this all comes out to being 144 minus 36 minus 48, which is 144 minus 84, which is 60. So the area of my red triangle is 60 meters squared.